Hey guys, welcome back to the Espresso Outlet YouTube channel. Today we're going to do more of a maintenance and troubleshooting type video. Now we're going to use this Turin Gallatin as our test subject. There's not anything currently wrong with it. We're just going to use it as an example machine. Now you can apply most of this to other brands like Lillet, Rocket, ECM. It'll probably make the most sense if it's an E61 since that's what we're looking at today. But even these techniques, they do apply to other brands of machines like the Legato, some of the other styles of machines out there. So to begin with, we're going to go through some of the common internal components of these espresso machines. I have a couple tools in front of us. You really don't need a whole lot. It's going to be specific to your machine if you need more tools than this. To begin with, I would recommend some sort of a screwdriver. This is like a Klein Tools 11-in-1, so it's going to give you the flatheads and different sizes, and you can flip it around. It also functions as a bit driver. Some machines, the bottom screws are actually kind of a bolt, so you might need some sort of bit driver or a wrench. It takes a little bit more to get them off. Luckily, this machine uses Phillips heads, so getting in is going to be very easy. Something like this, very, very useful. Another thing that I like to have handy, at least to pull back some wire terminals, is my just inexpensive needle nose pliers. Something that I always have pretty handy. Last, this one is kind of costly, but some sort of a digital voltage meter, and we'll go over some of the functions of this. I'd probably recommend like a Klein brand, the same as this. They're usually about $30 at like Home Depot or Lowe's if you need to use this. Now, I will give just a quick disclaimer. This is just if you want to troubleshoot your own machine. If you don't feel comfortable doing this, especially with like live electricity, you can damage the machine, you can hurt yourself. So I would recommend taking it to a technician if this isn't something that you feel comfortable doing. But more informational about the internal components, and it might give you the confidence in potentially digging into your machine if it was to ever have this minor issue that you need to fix. So I would say to begin with, ensure that your machine is unplugged. We may plug it in a little bit later to show you some of the other things, but the majority of our troubleshooting is going to be done unplugged. Okay, so to begin with on this machine, a little bit boring, but we'll remove the door to the water tank and the water tank. I just like putting them to the side. Make sure that there's no water in them. And at least in terms of the Gallatin, getting into the top, very easy. You just lift off this cup warming rack spacer, and you do have some screws underneath. Now, as I mentioned, you may need some additional tools, and I did make the error. I have another Gallatin that has Phillips heads. This one actually uses a T-handle Allen screw. So we're going to begin by removing this barrier. Okay, so we're going to begin by just looking at some of the top components. Again, your espresso machine may be a different brand. Sometimes the heating elements are located on the top, side, or bottom. Your boiler could be located on its side, etc. But again, most of these parts are going to be the same throughout. So issue number one that we hear sometimes is my boiler is not filling up, or it's overfilling, and my machine isn't working properly. So the first probe is this probe right here. The way that it works is it is going to make some continuity between the water and the frame of the machine. So when this gets a small amount of current through it, it's going to know that your boiler is full. Similarly, if you were to pull some shots, it's going to begin to drop inside your boiler, and then it's going to know to refill your boiler. So why is this a big deal? Well, sometimes these do get corrosion on them, and you need to pull them out and clean them. The other reason that we see is you're using too pure water. So we say don't use RO water. The reason for that is RO water doesn't conduct electricity. So if this is not able to conduct electricity through it, it's not going to know that the boiler is full. It's actually going to just continue to run and run and run until it's over full. If for whatever reason you needed to clean this probe, different machines kind of are different styles in how they work. Some of them you'll need to undo that nut, and some of them just undoing that nut a little bit will release it. Some of them you have to completely unscrew the nut. Oftentimes I do see them where they are able to pull out directly. I kind of don't recommend doing that. You don't want to ruin the seal. Okay, so I went ahead and took off the side of this Gallatin. Really easy, just undo two screws at the top and bottom, and the side panel comes off. And we're going to take a look at the next thing that sometimes happens, especially if you kind of neglect your machine or as espresso machines get older. And that is the heating element. And we'll get calls, people say, every time I turn it on, it trips my GFCI breaker. Now, there could be many reasons for this, but 9 times out of 10, it's because your heating element is bad. So what happens with really corrosive water, the heating element will actually get a little pinhole in it, and that water is going to essentially trip that GFCI breaker in your house. So to test with that, we're going to need our voltage meter, and I typically recommend taking these wires off. I'll show you with and without taking it off. The reason why I like to take it off is because if you have some sort of a short elsewhere in the machine, it's going to help you isolate and know that it's not your heating element. So to begin with, we have our voltage meter here, and this is a multimeter, so we want to set it to the ohms. It's kind of like a horseshoe symbol. And if we touch it together, you can see that we have really good continuity because they're touching. When it says OL, that means open line. That means that there's essentially nothing between the two terminals. So to begin with, let's just test this. It's in good condition. I would expect it to be, I don't know, 10 to 25 ohms. So there we go, 10. That's a really good resistance. Let's go ahead and just take these wires off real quick, and I'll show you the difference. Okay, so with this taken off, it might be a little bit higher because it's not going through a circuit. And it's pretty much the same. So that's good. That means our machine is just pretty much in good health and brand new. So I wouldn't expect it to be that crazy. Now, you will notice that this has actually 2 heating elements, but it's built into one heating element. So this is a loop and this is also a loop. Now you might just have one that is damaged. And in this case, you'd have to replace the whole heating element. So it's really not the end of the world. Some of them, they will have individual heating elements, so you may need to separate out the wiring. This one, they're actually welded together, so you don't have a good way of testing them individually. But again, if they're bad, you're replacing that whole heating element anyway. Now, while we have the wiring off, the next thing that I usually do to test my heating element, you may have that pinhole in there, and only one side is giving the issue. So to help you isolate that, we're going to check it to ground. And the best way to do that is just to take one of your probes and put it on one of the sides, and then to put it to the body of the machine. And here you can see that it says open. That means that there is not any sort of a connection between the heating element and the frame. And then I would change it to the other side of the heating element, because sometimes when you get those pinholes, it's only going to conduct electricity on one of the two sides. And again, this heating element is good. If we were to touch it together, you'd see a very low resistance. If we touch it side to side, we'll see that 10 ohms that we had earlier. Okay, so on to our next test. If we've tested the heating element and it has a good ohm reading, and we've tested our overload and it doesn't appear to be triggered, and it's still in good functioning shape, the next thing that I would look at is just to see if you're getting power at your heating element. Now, I did go ahead and plug this espresso machine in, so if I were to touch those terminals, it would send you a shock. So if this is something that you're not comfortable doing, I don't recommend doing this. Bring it to a technician maybe at this point. But in this case, just to show you how it works, I did have to go put the water tank back in, and it does have some water in it so that it doesn't give the low water alarm. And I'm going to take my 2 probes and touch it on either of these. And you can see that we have normal home voltage of 100 and essentially 18 volts, and that's what we want to see. Now, if we're not getting voltage there, there's multiple reasons. One, if your machine is hot, your PID or pressure stat is going to turn off this heating element. So this heating element, it does not run all the time. A lot of people, they think their machine's on all the time, so it's pulling power all the time, and that's not true. So with the PID, we have a solid state relay, and there's a temperature sensor on the boiler. So it's essentially like the thermostat in your house is really how I try to explain it to people. When the boiler gets too hot, it turns the heating element off. So it's a little bit backwards from your home. When it gets too cool, it turns the heating element back on. So if you're testing this and it's showing 0 volts, it could be just because it's hot. Now, if you wait a minute, hold it on there for a minute or two, open up the group head so that the temperature does drop, you should begin to see that voltage. The reason I mention this is it could be a bad solid state relay. I don't think I've ever seen one go bad, but they do turn on and off very quickly. More common is on older espresso machines, they have a pressure stat. And similar to this temperature probe, when the pressure drops, it knows to turn the heating element on. And when the pressure increases, it turns the heating element back off. So really what happens with these, they're really not the most precision piece to begin with, and they will get corrosion inside of them. Sometimes they'll get stuck in that off position. So everything else seems like it's working. Your pump turns on, but it's just not heating up. I would probably check your pressure stat, at least if it's an older machine with the pressure stat. Continuing on with some things that may be an issue. I'll see this a lot during like shipping transit for whatever reason. Sometimes these do pop out, or they will pop out kind of fairly early on with a new espresso machine. There are these thermal overload buttons, and I can hardly reach my finger in and have you see on the video, but it's right there. You see the little nub in the middle is actually a button. In a lot of espresso machines, this nub will be red so that you can see it a little bit more easily. And the first thing that you should do is just push it in, because it's acting as a thermal switch, and if it's popped out for whatever reason, you're not going to get power to your heating element. Next, these do go bad from time to time. I'm going to put my probes on, and this one is closed, so if the button's pushed in, we should get a very low ohm reading. Sorry if I'm a little bit too close. It's 0.1 ohms, so it should be very low. It shouldn't be open line. It should just show that it's passing through. So that's the next thing that I would check. The next thing that we're going to take at is our temperature probe. So if you have a multi-boiler machine, you're going to have more than one of these. You'll have one for your brew and one for your steam. In this case, since this is a heat exchange machine, we just have the one. You can see it right here. And usually what will happen is one of these wires will get hit and break off. They're usually very low resistance wiring. And the reason for that is so that it gives you the most accurate reading. But because it's very low resistance wiring, it means it's very small and very fragile. So sometimes this wiring will become damaged and your machine, for whatever reason, won't heat up because it's not getting a signal. Now with the modern machines, it's going to tell you that something's wrong. It's going to give you an error message, but we do have a way of testing it just to see if this is what our issue is. So again, we're going to go to our voltage meter and we're going to put it back on the ohms reading and just very gently unconnect these wires. It can be a little bit difficult. Not all of them are the same, but you can see 2 contact points at the top, and that's what we're going to do a quick test on. So if this probe were bad, it's either going to say OL because there is no continuity through that probe, or it could also be a really high reading, meaning that one of these is going to the base of it. There are grounded, we don't need to go into all this stuff, but if it's very low or very high, there's a big potential that this is damaged. So I'm going to take this. It's going to be a little awkward to reach in there. So we have 29 kilo ohms. It's very low reading. That's something that we would be happy with seeing. If it was something like 10 ohms, I just kind of let it go. If it's something like 10 ohms, that would tell us it's probably going to the body of the machine, or if we touched it, and just, you really kind of have to dig in there to make sure that they connect. But if we had that OL, we would know that probably one of these wires is broken and this probe is bad. Okay, so the next component that I want to take a look at is a solenoid valve. And a solenoid, really what happens is when you run electricity through it, it creates a current and a coil, and it's going to pop a little plunger in and out. So this is one of our solenoid valves. I did go ahead and just loosen this real quick. This one's really cool because it has an LED built into the top. Not all of them have this, but it's going to tell you when that solenoid is either open or closed. So to test it, I'm going to remove this boot, make sure that your screw doesn't fall out. And it should be open between this bottom and the top and the bottom and the top. So let's do a quick test. It should have, put it back on your ohms, it should have nothing between this bottom one and the top, and the bottom one and the top. This is your ground at the bottom. And between these two, it should just be a very low reading. So 0.664 kilo ohms, very low. And really all that is measuring is through that small inductive coil. Now, if you were to touch these two together and it said OL, open line, you would know that one of these is burned up. So that's the electrical way of checking this. This one is a little bit more difficult to get to, and I don't want to take it all apart. But if you needed to replace the plunger, sometimes, again, if you have that poor quality of water, your plunger will actually get stuck on the inside, and this whole assembly will need to be replaced. So it can be a little bit more difficult to troubleshoot, but you'll know if you're getting power and it's at least attempting to open and you're not getting water through, you're most likely going to need to deep dive into why that plunger isn't actuating. Continuing on, and it might seem a little bit silly, but we do see these toggle switches fail from time to time. Seems to happen on pretty much every brand. You'll see that we have our main power switch. This can be in various locations, and we have our terminals on the back. Again, this is unplugged. And then at the top, at least on this E61, we have our three-way valve. And when we open up our three-way valve, it's pushing a button right here to turn on your pump. So sometimes you'll flip up that arm, and for whatever reason, your pump doesn't turn on. These little limit switches are pretty robust, but they can go bad. So let's do a quick test. I actually have the meter set on the tone sound. You could look at your ohms, but I'm going to, it's in the off position. Again, unplugged, hold it like this, and then we should hear a tone. So when I turn it on, it makes connection. So we know that our switch is good. Now, just because it goes through, I would still inspect to make sure that you didn't hit the front and maybe crack it somehow, and it's still partially bad, really easy to swap out. So our switch that turns on the pump, sometimes they do it in different ways. Sometimes pulling it up is actually going to make a connection. In this case, it actually disconnects it, and that's what tells it to turn on. It's kind of more of a safety thing. So if this were to ever break, it's not just going to run. So they actually have it set up in a more fail-safe mode. If I were to put these, we'll hear a tone. It's in the down position, and when I raise it up, it's going to stop the tone. So we know that this switch is in good condition. Okay, so on to our next topic that we see come up fairly regularly. They say there's no water in my tank. On this machine, I think it's like F3. Some machines, they say low water. Some they just beep, have a light. Every machine is designed a little bit different. But for whatever reason, your water reservoir is full and it's giving you the alarm. And on all these different brands, they all kind of choose to do their own flavor of it, but it's usually one of two ways. One is a small float sensor. And if you look, it's really hard to see. At the bottom, it's just a magnetic float that goes up and down. And right here on the side of our water reservoir enclosure, there is actually a small sensor. So when the water goes up, it moves that magnet up, and it knows it's at least full up to there. When it runs out of water, it's going to tell you that you need to add water. So why do I bring this up? Well, sometimes these floats do get stuck. So you might need to wash out your water tank, move that little plunger up and down, and ensure that it's in good operating condition. The other method that I've seen done, and it's done quite often, is similar to our boiler fill probe. So our boiler fill probe, if you remember, it takes the small current and it runs it through the water, and then it tells the machine that there's water in this tank. So you'll have two little probes on the side or something that sticks down from the top, and as long as those probes are wet, it has water in it. Now, where I see a lot of people run into issues is if you're using some sort of like distilled or really pure RO water that we don't really recommend for these machines anyway, it's not going to sense that there's water in the tank. So I'd recommend, I wouldn't say tap water, but if for whatever reason you're just doing some quick testing, you can always fill this up with some more hard water, some tap water, and at least see if that fixes your issue. If that doesn't fix your issue, you may need to dive a little bit deeper into it. All right, so before we finish up this video, I do have a handful of really important comments. So this is an E61 style heat exchange machine. Now, if you were to do your troubleshooting and it's a Gallatin dual boiler, for example, you have that second boiler, meaning that you have a lot more components to test. So on this machine, we tested our heating elements on the only boiler that's in it. For a dual boiler, obviously you're going to have 2 sets of heating elements, sometimes 3, sometimes 4, depending on how the manufacturer has it set up. You'll also have additional thermal overloads to test. You'll have additional fill probes to test and temperature probes to test. So you can see it's going to add up a lot more if you have that dual boiler machine. You're going to have multiple items to test. So the next thing is, this is an E61 style machine. There are other espresso machine designs out there that have like saturated group heads. More or less the internal components are going to be the same. It's just really where they put them. Like on a lot of machines, they put the heating element in the bottom. I think it's kind of a pain. So testing your heating element or even swapping it out is usually a lot more work when it's not on the side like this. But you should be able to take some of these techniques to test your solenoid valves, your heating elements, your temperature probes, and so on. So I think this pretty much concludes the video for today. If you have any comments, make sure to comment below. If you have any specific questions on your machine, I do recommend reaching out to a technician rather than asking comments below, because we're not going to be able to really help over YouTube. But I hope this gives you some ideas of a few things to test for and look for if you wanted to explore maybe what's wrong on your own. For today, thanks for watching. Consider hitting the like and subscribe. We'll do more maintenance videos like this in the future. We'll see you next time.